Turning. Nomenclature of single point cutting tools. Content covered. 1. Name the types of cutting tools. 2. State the nomenclature of single point cutting tools. Lathe cutting tools are divided into two groups. These are 1. Single point cutting tools. 2. Multi-point cutting tools. Single point cutting tool nomenclature. The tool acts as a wedge during turning. The wedge-shaped cutting edge penetrates the work and removes the metal. When we sharpen a pencil with a penknife by trial and error, the knife must be presented to the wood at a definite angle if success is achieved. If in the place of a wooden pencil, a piece of soft metal such as brass is cut, it will be found that the cutting edge of the blade soon becomes blunt and the cutting edge gets crumbled. The cutting edge must be ground to a less acute angle for the blade to cut the brass successfully. The angles given below may not be located or found in every tool. Tool nomenclature. Cutting tool nomenclature systematically names a cutting tool's various parts and angles. 7 tool nomenclatures are generally used to define any single point cutting tool. These are as below. 1. Approach angle or side cutting angle. 2. Trail angle or end cutting edge angle. 3. Top or back rake angle. 4. Side rake angle. 5. Front clearance angle. 6. Side clearance angle. 7. Nose radius. Before going into more detail about the various nomenclature of the tool, let us first know the parts of the tool. For example, the single cutting point tool has the following parts: shank, base, face, end cutting edge, side cutting edge, minor flank, major flank, nose and heel. Now let's discuss tool nomenclature in more detail. Approach angle or side cutting angle. The side cutting edge angle is the angle between the side cutting edge and the side of the tool shank. This angle prevents interference as the tool enters the work material. However, this angle affects the tool's life and surface finish. In addition, the larger value of this angle will tend to separate the tool and workpiece, resulting in chattering. An angle of 15 degrees has been found satisfactory. The cutting will be oblique while cutting. The oblique cutting has the advantages over the orthogonal cutting, in which the cutting edge is straight. More depth of cut is given in the case of oblique cutting, since when the tool is fed to the work, the contact surface of the tool increases gradually as the tool advances, whereas in the case of orthogonal cutting, the length of the cutting edge for the given depth fully contacts the work from the beginning itself, which gives a sudden maximum load on the tool face. Consequently, the area over which heat is distributed is greater in oblique cutting. Trail angle or end cutting edge angle. This is the angle between the end cutting edge and a line normal to the tool shank. This angle provides a clearance to the trailing end of the cutting edge to prevent rubbing between the mechanical surface and the trailing non-cutting part of the cutting edge. The approach angle and trail angle ground will form the wedge angle of 90 degrees for the tool. An angle of 8 degrees to 15 degrees has been found satisfactory. Top or back rake angle. The top face of the tool over which the chip flows is the rake face or face. So, it is also called as top rake angle. The top back rake angle tool is ground on the top of the tool, and it is a slope formed between the front of the cutting edge and the top of the face. If the slope is from the front towards the back of the tool, it is known as a positive top rake angle. And if the slope is from the back of the tool towards the front of the cutting edge, it is known as a negative back rake angle. The top rake angle may be ground positive, negative, or zero according to the material to be machined. For example, when turning soft, ductile materials which form curly chips, the positive top rake angle ground will be comparatively more than turning hard brittle metals. When turning hard metals with carbide tools, it is usual to give a negative top rake. This is because negative top rake tools have more strength than tools with positive top rake angles. The recommended value of the back rake angle is 5 degrees to 8 degrees. Side rake angle. A side rake angle is a slope between the side of the cutting edge to the top face of the tool widthwise. The slope is from the cutting edge to the rear side of the tool. It varies from 0 degrees to 20 degrees according to the material to be machined. The top and side rake ground on a tool control the chip flow, and this results in a true rake angle, which is the direction in which the chip that shears away from work passes. Front clearance angle. It is the slope between the front of the cutting edge to a line perpendicular to the axis of the tool drawn downwards, which is known as the front clearance angle. From the top to the bottom of the tool, the slope permits only the cutting edge to contact the work and avoids any rubbing action. If the clearance ground is more, it will weaken the cutting edge. Side clearance angle. The clearance angle is the slope formed between the side cutting edge of the tool with a line perpendicular to the tool axis drawn downwards at the side cutting edge of the tool. The slope is from the top of the side cutting edge to the bottom face. This is also drawn to prevent the tool from rubbing with the work and allows only the cutting edge to contact the work during turning. The side clearance angle needs to be increased when the feed rate increases. Clearance angles range from 5 degrees to 15 degrees. Nose radius. It is the curvature of the tool tip providing strength to the tool nose and a better surface finish. It is expressed in millimeter. Proper tool nose radius improves machinability to some extent through an increase in tool life by increasing mechanical strength and reducing the temperature at the tool tip. In this video, we have learned about the nomenclature of a single point cutting tool. Thanks.